Hi folks, so this is question 7. So this is the first part of section B of the paper. So it's going to be a little bit longer, maybe a little bit harder. The first thing you have to do is it gives you a function. So it gives you a big awkward long function like that with decimals in it. So that's not uncommon here for section B. So you have to basically you're just putting in, you're subbing in a number for x each time. So first of all, you're putting in 0, and then you're putting in 2, and then you're putting in 4, and then you're putting in 5 instead of x. So you need your calculator here. So if you put in 0, you'll get minus 0.38 times 0 cubed plus 2.6 times 0 squared minus 0.13 times 0 plus 158. So that's how you get your value for the first one. And if you put all that into your calculator, you can do it in your head actually, that one, because it's just times in 0 for 3 of them, and then the 158 is just left over. So 158 goes there. Or if you put all that into your calculator, you'll get 158. For the next one, then you're going to do the same thing, but I'm not going to write it out and do all the work here, but you're just putting a 2 in instead of 0 that you put in the first place. So you're putting a 2 in there instead, and you're putting a 2 in there instead, and you're putting a 2 in there instead. And you put all that into your calculator again, and this time you should get 165. And then you do the same again, but now you're putting a 4 in, so you put a 4 in there each time, and when you put a 4 in there, you'll get 175 when you round it off, actually, because you have to round them off to the nearest whole number. And then you do the same thing again, but you put a 5 in there, and you'll get 175 again. So I'm not going to write it out each time because I don't think I need to. But that's what you do for the first part. Second part, then, you have to just plot them on the graph, I think. So 0, 158 is the first one. So you go across 0 and up to 158. So 158 would be about there. And then 1, 160. So you go to 1 and then up to 160. And that'll be above it, it'll be there. And then 2, 165. Go across the 2 up to 165. So it's going up gradually here. And 3, 171 is already given for you. Would be about there. Maybe a little high actually. 4, 175 is there, and then 5, 175 is the next one. So that's just going to be beside it there like that. And then the last one is 6, 169. So the last one is already plotted for you. So you can just join them up. Then you just have to be careful and just fit in the curve as best you can. So the curve should go a little bit above those 2 points as well, because it kind of goes up and down. Part A finished. So we'll need to do more than with the graph for part B, I expect. So explain what the coordinates of point A 6, 169 represent in the context of Joseph's heart rate. I didn't actually finish off the graph there. So 6, 169. But what this means in the context of the graph is that, well, the 6 represents 6 minutes, and 169 represents 169 beats per minute. So after 6 minutes, so something like this, after 6 minutes, Joseph's heart rate was 169 beats per minute. So that's what it means in terms of, in the context of his heart rate. So using the same scales, same axis and scales, continue your graphs of that. From the point 6, 169, his heart rate stays at the same level for the next 2 minutes and then decreases at a steady rate of 10. So then it goes down by 10 beats per minute for 2 minutes. Okay. So the first little bullet point there, it stays at the same level for the next 2 minutes. So we're on 6 minutes here at the point 669. So it stays at the same rate for the next 2 minutes. So let's just go on to 8 minutes then. And it's going to stay on the same. So it's going to be a horizontal line across like that. That takes us up to 8 minutes then. And then the last bit, it goes down. What did it say again? Yeah, it decreases at a steady rate of 10 beats per minute. So per minute for 2 minutes. So for the next minute, it's going to go down by 10. So by the time we get to 9 minutes, it'll have gone down by 10, and then it'll go down by another 10. So it'll go down to 160 there. And then for the next minute after that, it's going to go down by another 10 as well. So that's what per minute means. So that would be, put a point on that as well. It should really be kind of a straight line. You could draw that down with your ruler. So during his training session, the number of calories per minute that Joseph is burning after X minutes can be modeled by C of X. So um, where H of X is his heart rate at that time. So use the information in the table or graph to work out C6, the number of calories per minute that Joseph is burning 6 minutes after the start of the session. Okay, so it's like there's a function within another function here. So quite simply anyway, C6 would be where you put in a 6 instead of X. So it'd be 0.1 times H of 6 minus 7. So you have to actually know what H of 6 is then. But if you look back up to the very top up here, you do actually know what H of 6 is. Calculate it. H of 6 is in the table. So it's 169. H of 6 is actually 169. So you can put that in instead of H of 6 down here, and then you've got all numbers. So 0.1 times 169 minus 7. Okay. So you can put all that into your calculator then, or you can kind of see that 0.1 times 169 is 16.9, and you take away 7 from that, so you're going to get 9.9. So 9.9 is your answer. That's what C of 6 is. So that's calories as well. So 9.9 calories. Right, part E. So we're getting there now. Joseph has a smartwatch that beeps every 15 seconds during the session. It beeps for the first time at exactly 2:55. As Joseph starts his session, it beeps for the last time at exactly 3:23 as he finishes. So if it beeps every 15 seconds, well, there's 15 seconds in an hour: 15, 30, 45, 60. So it's going to beep 4 times every minute, 4 times per minute. And you can work out how many minutes there is. So if it starts at 2:55, finishes at 3:23, well, it'll be 5 minutes till 3 o'clock, and then another 23 afterwards. So 5 and 23 is 28 minutes. So you've got 28 minutes altogether, and it beeps 4 times per minute. So we do 4 times 28. So 4 times 28 are 112. So that's how many times over the 28 minutes. Now, there's one other little tricky bit here. It beeps sort of first. Look back up the question. It beeps for the first time at exactly 2:55. So we haven't actually calculated that beep in our answer, because if you imagine at 255, and then we've started from 15 seconds on from there. So our first one that we've kind of calculated in here is 2:55 and 15 seconds. And then the next one is 2:55 and 30. And the next one is 2:55 and 45 seconds. And then the next one after that will be 2:56 minutes. And the next one after that is 2:56 and 15 seconds. So we haven't allowed for that first beep. So we have allowed for the last one because it worked. The fourth one each time is on the minute. So we have to actually just add one here. So 113 is going to be our answer. So solve the equation h dash of x equals, and it gives us an equation equals 0. So to find how long after the start of the session Joseph's heart rate is at a maximum for between 0 and 6. So give your answer in minutes, correct places. Right, so this is actually just a quadratic, really. If you look at that part there, don't really worry about the h dash x too much for now. So to solve that quadratic in there, you have to use the quadratic formula, obviously. So you're not going to be able to find factors, kind of an equation. So b minus b plus or minus b squared minus 4ac. So this is in your log tables again. So you need this to solve quadratics. So a is here, a is minus 1.14. B is 5.2, and C is minus 0.13. So if you sub them in, 5.2 plus or minus square root of 5.2 squared minus 4 times minus 1.14 times C, which is minus 0.13. All over 2 times A. So A is minus 1.14. Okay, so easiest thing then, you need to be good with your calculator here, obviously. Uh, you're going to get two different answers. So you're going to get where you do 5.2 plus all of that over 2 times minus 1.14 and 5.2 minus the big square root, everything and that, all over 2 times minus 1.14. The easiest thing is to put it all into calculator with a plus in there, and that's one answer, and then change and put a minus in there instead, and then that's your other answer. So your two answers are going to be 4.54 and 0.03. So you're getting two answers here. You always will with the quadratic formula, well, generally. So we don't want two answers. So the question was to find out how long after the start of the session Joseph's heart rate is at a maximum. Okay, so at what point is it at a maximum? So let's look back up the graph here. Yeah, so his heart rate is at a maximum around here, isn't it? It's well, to be more specific, it's in between here. Okay, so it's something in there. So it's 4 point something, or it's between 4 and 5 really, if you look down here at the bottom. So it's between 4 and 5 minutes. So therefore uh, it has to be the answer with 4 in it. Yeah, it has to be the 4.541. So that has to be your answer. It can't be 0.03 because that's way back at the start. It's definitely not a maximum there. So 4.54 minutes.